So, hello and welcome to today's webinar about spotlighting the darkest corners of your plant with predictive analytics, presented by our partner Precognize. My name is Ayrton from WeConnect, and I am delighted to introduce our two speakers for today's session. On the one hand, we have the Precognize CEO, Chen Linchevsky, who will lead you through his presentation in the next couple of minutes. I think it will be about 30 or 35 minutes. And afterwards, he will be joined by his colleague and Precognize CMO, Liad Avidor-Belek, for the Q&A session. One last advice from me before we start, speaking about Q&As. If you have a look at your control panel, you will find a tab called Questions. You can just click on it or click on the tiny arrow next to the word questions, so it will open up and you can directly enter your questions there, if you have one. So please don't be shy and ask your questions during the webinar. I think our experts are happy to get them and to answer them in the Q&A session afterwards. So that's it from me for the introduction. I guess, Jen, we're good to go. Have fun.
Okay, so thank you all for joining this morning or afternoon, depends on your time zone. As was mentioned, my name is Chen Linchevsky. I'm CEO of Precognize, and I'll talk about spotlighting the darkest corners of your plants. Before I start, a word about us. Precognize is a software company. We're now part of Samsung Group, just been acquired a few months ago. So we're actually combining our software analytics capability that coming from Precognize together with Samsung capabilities in the flow control, providing to our customers a global presence in almost any country, every country across the globe. We serve customers, most of the major chemical, petrochemical, oil and gas companies within our customer list. Now, we have a very specific job. Okay, our job is to offer the best failure prediction solution for those specific industry, for the process industry, whether it will be chemical, petrochemical, refinery, steel plants, cement, and so on. And for those industries, our job is very specific. All we need to do is to tell the operation people that something is going to go wrong, and we need to do it early enough so they can prevent the failure and continue a smooth operation. Okay, so sounds simple, and we try to make it simple, and this is the exact job that we're providing. Now, in this presentation, I would not try to convince you to license Precognize. What I would like to try to convince you is what's the right strategy when you're talking about predictive analytics, predictive maintenance, predictive monitoring. Now, I'm sure many of you have done some activities in terms of trying to predict failure of equipment. And many of those companies, what they're looking for is to predict the most expensive or the most the equipment that doesn't have redundancy, and to try to predict this failure. So the most expensive compressor, which doesn't have redundancy, and if it fails, the plant is down for 30 days. So all companies are going and trying to predict this aspect. Some of them are adding to that what we call condition-based monitoring, which means that, okay, for some equipment, we will try to, from time to time, check the equipment. If we don't see cracks, if we don't see any things that will trigger alert, then we continue and use them until we see those things. Now, condition-based monitoring is something which can work for some of the elements, some valves out there, maybe some pumps, but it's not across the organization. It's here and there within your plant, things that you can absorb if they would fail. Now, others are doing the third option, is to basically say, okay, I have a problem. I already experienced this problem. Now I want to handle this problem, try to predict when this problem will occur again. Now, what life taught us is that the things that happen in the past will not necessarily happen in the future. So the fact that you're looking for problems that already occurred would not necessarily help you in predicting the future failures. Now, what we're trying to pitch for, and I think this is the real value proposition when you talk about digital transformation and Industry 4.0 and all these kind of big words about how to use data. What we're trying to pitch for is predictive monitoring for everything, for your entire plant. Because actually your plant has so many parts. It has valves and pressure vessels and boilers and compressors and conveyor and catalysts and reactors and heat exchanger, and I'm sure many other components which I didn't mention here. Each of these components may fail. Each of them may cause you maybe a few minutes, maybe a few hours, maybe a day of shutdown, of lost production. Okay, each of them may cause you to get a phone call in the middle of the night. We have a problem. What do you think we should do? Okay. So from our perspective, we don't see a reason to focus only on the most expensive equipment that actually almost never fail because it's so critical. We don't see a reason to focus only on those that can do condition-based monitoring, and we don't see a reason to focus on past failures which will not necessarily happen in the future. We see a reason to focus on everything because everything can cause you a failure. And just to give you an example from one of our customers, they had this customer is based in next to a city, and they had a flare event. Now, a flare event is, of course, it's in the news, it's bad PR, it's material that's going to the air without any reason. We all agree that flare event is not something that you want to experience. This flare event was caused by a very simple element, a valve, okay, and actually a mechanical valve that was installed there and was sticky for a while. And because of that, the system stopped and had to release the pressure, of course, and this pressure went to the air, and then bad publication and so on. Now, this event happened on the 1st of September. We demonstrated that this event could have seen 3 weeks before. Okay, so 3 weeks in advance, we could tell this operating team in this plant, listen, you have a problem with this valve. And this is exactly what we're doing there today. We're covering hundreds of valves, hundreds of pumps, towers, whatever, and we're pinpointing for them every day where is their next problem going to be before it actually caused this flare event. So there is a problem here of failures. There is a potential of saving, and the other nice thing about it is that you already have the data. Okay, because all what we do is that we analyze data, and most plants in the process industry, from the sophisticated chemical, petrochemical to even other plants which are less sophisticated, all of them have thousands of sensors, and those thousands of sensors are going to the DCS, and those thousands of sensors for most plants are going from the DCS to the historian, where the history of this data is being stored. So we have the process data, we know the temperature, level, flow, pressure, and so on. And in some cases, less frequent, we have also equipment data such as current, vibration, temperature of the bearing, and so on. So there is a mountain of data that is being collected in those plants. Okay. And by the way, today from what we are seeing, this mountain of data is actually not very heavily utilized. Okay, the process engineer would look at 20, 30, 40 tags a day, but nobody can actually look on thousands of sensors every minute and try to identify where there is a problem. And that's exactly what we're doing. We're taking this data, which you're already collecting from the sensors you already have in the plant, and we analyze it in a smarter way in order to eventually tell you, listen, check this valve, check this pump, check this leakage in the heat exchanger, because there it's your next problem. And this is what we're trying to do, an early detection. Now, it's very different from when you see that, just keep in mind that when we're telling you, listen, you have a problem, it's probably these 3 weeks in advance. It's going to be there. Check it now or experience a failure in the future. Now, the benefits are pretty clear. It's always that you have dark corners are dangerous and scary, and it's and the first thing that comes to mind is the direct cost of failure. Okay, if you have an hour of shutdown, or if you have a day of shutdown, you can calculate better than I do how much money it costs you. Okay, and when I'm talking to customers, and some of them are saying, yeah, but we are already monitoring the compressor, we already have some kind of analytics. Yes, we have some trends in our historian that we're looking at. I have a very simple question here. Do you still experience failures, or do you have no failures in your plant, no unplanned failures in your plant? And if the answer is everything is smooth, no failures, then you can listen to the rest of the presentation, but I don't think you'll gain any value. But I haven't seen, or almost haven't seen, a plant that doesn't have unexpected failures. And if you're still experiencing unexpected failures and you have the data there, I just don't see a reason why not to try to prevent it. So this is the benefit which can be easily measured, by just putting a dollar sign next to each hour that you're not producing. But there are more. There are more benefits. One of them, which is very major for the operation team, is that you stop chasing fires. Okay, it's not that you have to address things which are already happened and you have to do it as fast as possible. It's actually, that something is going to hit you. You have time to think about. You have time to get ready for that, and you have time to plan. And this is very valuable when you operate these kind of plants, especially when these plants are supplying to other plants which depend on the material that you're producing. Another what we call soft benefit is that remember, when you use a software, it means that you have less hardware and less manual work. So instead of replacing all those equipment parts which may fail, which is very costly, and instead of doing hundreds of walk around to the equipment to try to identify the leakage, you can use the software. It's a fraction of the cost. And finally, what we hear from our customers, and this is not something we expected at the beginning, is that there is a change in the way people are managing the plant. Because from talking about gut feel, you're actually now talking about data. You're talking about facts. We had several plants where when we came in, they said, oh yeah, it's very unstable, we have many failures. And when we started, we saw that the situation is not that bad. And we also had the opposite. People are acting a lot about gut feel. And one of the benefits from using the data for predictive monitoring is that now everything is based on facts. Okay, but you have to keep in mind that this is a change in paradigm. Okay, it's a change from what you're doing today, which is mostly reacting to what is happening, to an approach which is predictive, which is what's going to happen. How are we going to deal with this situation, which is going to hit us in the future? And now we have many alternatives. It's a completely different ballgame. From reacting to something which has probably one solution, let's replace it. Now you have many options. Maybe I should go to the redundant system. Maybe I should reduce the flow on that pump or valve, and from there reduce the probability of failure and keep it until the next maintenance, and so on and so forth. And this is influencing the people and the process and the equipment that you may need, because it may be that your people there are really data savvy and they think about the different alternatives, but you may have people who are, they're used to the way they did things for 20, 30 years. So you have to think about this as a change in paradigm. Okay, so the one thing that we're bringing when we're talking about predictive monitoring is that we're actually changing the way you operate your plant, and this is something that has a lot of potential, but it requires a change. Now, I will not go deep into technology and how much how we do things, but just to give you a feeling about when we're talking predictive maintenance, predictive monitoring, what do we talk about? Now, when we started, there were few requirements. The first requirement that people told us is, listen, we have a control system. We have hundreds of alerts in the control system. We don't need another system that will trigger hundreds of alerts. Even if these alerts are predictive and even if these alerts are great, like you're saying, we just don't have the capacity. It doesn't matter. Okay. So what we're limiting ourselves, and this is, I think, one of the biggest advantage of the way we work, is that we're limiting ourselves to up to 5 alerts a day. And think about your plant. Probably you don't have more than 5 failures a day. So this number should be completely sufficient. Up to 5 alerts a day. Now, to tell you, listen, you have a problem, I don't know exactly where, go figure, is again, it's not a solution. So the other requirement was, please be clear and pinpoint the problems. Tell us that it's a problem with this valve. Tell us it's a problem with this pump. Tell us it's a problem with this heat exchanger. Don't tell us there is a problem, something in this section, or there are anomalies in the plant, which we don't really know what they are. Okay, so pinpointing specific processes or specific part was part of the requirement. And finally is the time. Okay, if we're telling you, listen, you have a problem, and boom, it happened, then you cannot do anything about it. Okay, in the course of action within the process plant, you need some time to react, and this time is from hours to days to 3 weeks, like we have seen in the example before. But just to set the expectations right, from our experience, we're not talking about 6 months. Okay, and we had the requirement from some customers saying, listen, the lead time for this part is about 6 months. Can you predict 6 months in advance? We tried, and from the real life, teach us that yes, we can predict some days in advance, we can predict some weeks in advance, but beyond that, there are so many changes in the plant that it's not really predictable. Now, in terms of technology, there are various technologies out there. Okay, and all plants that I know of have a control room and have a control system, and many alerts there, and this is nothing about predictive. Okay, this is the traditional monitoring. It's nothing about predictive monitoring. It's just the same traditional thing. If something is there, it's already too late. It's already happened. And to that, you can add some rules that people are implementing, saying, okay, if I have pressure difference beyond something, I want to trigger an alert. But again, this is it's not very predictive, and it's very very simple. Now, I talked before about the option to predict things that already happened in the past, what we call specific prediction. And this is a valid approach, but it's a valid approach only if you have many historical cases. Okay, because in order to predict something that happened in the past, you need to have many cases of this thing. And if you don't have many historical cases, then your prediction will probably poor or even unavailable. So if you have a plant which every pump failed 100 times and every valve failed 100 times and so on and so forth, then you can maybe cover the entire plant by doing a specific prediction. In reality, this is not the situation. A pump failed once, twice, one time it was in summer, one time it was in winter. The conditions are completely different. So actually, specific prediction is good only in the rare cases and not in the general case of monitoring everything that can happen, let alone the fact that things that happened in the past will not necessarily happen in the future. So in terms of technology, when we're talking about predictive maintenance, predictive monitoring, we're talking about things that are coming from machine learning and are around finding when the plant, when the system, when the equipment is starting to deviate from its normal behavior. Okay, we're not saying, we're not trying to predict something that already happened. We're trying to see very, very, very early that something is starting to go wrong. And if something is starting to go wrong, it will probably give you those days to weeks in advance until you will really be affected by it. And this allows us to look at those thousands of sensors and try to identify what something is starting to go wrong within those thousands of data points. Okay. Now, the problem with identifying anomalies is that actually there are many of them, especially in the process plant. Okay, because a process plant, and you know your plants very well, a process plant is never stable. Things are moving, the ambient temperature is moving, production is changing, everything is changing. So, and there is so much data. So actually, at the end of the day, when you're running a machine learning engine, what you're getting are anomalies in the data. And those anomalies in the data are very, very different from problems in your plant. And if you're going to show those anomalies to the process engineer or show them in the control room, you're going to get hundreds of anomalies. It will be just as bad, or even worse than the regular control system. Okay, because machine learning is very, very sensitive, especially when you have so many sensors and such in a plant which is completely not stable. So what we understood, and again, I'm not going to go into the details about the Precognized technology, but what we understood is that in the process industry, you have to build a layer on top of the machine learning. And this layer is actually the way the plant is built and the main processes in the plant and how they are all connected to each other. And most of this is coming from the knowledge of the process engineer, of the people in the plant. And this allows us actually to be completely industry agnostic. I don't care if I'm running in the cement plant or I'm running in the chemical plant. What I do care is that there will be a person in the cement plant that knows his plant, and the same for the chemical plant. So what we have done is that we created a very simple user interface that allow the process engineer or maintenance engineer or other people who knows their plant to basically configure the structure, behavior, and the data connection of their plant. And this configuration, usually for a chemical plant, will take about 2 weeks, 2 weeks of work. And this configurations allows us to create another layer on top of the data. And this layer, which is internally actually represented as a graph, allows us to know how everything is affecting everything. And what is happening if you're opening the switch here or opening the valve here, what will happen to the temperature, to the pressure, what will happen next down the road. So we can actually go through the path of the causes within your plan in order to take those many anomalies that are triggered by the machine learning and pinpoint those 0 to 5 alerts a day, which tell you, listen, you have a problem with this pump or you have a problem with this valve. And again, I'm not going to go into details here about exactly how it is done. And if you're interested, you're more than welcome to contact us and to have a specific demo about the technology. But the bottom line is that we're taking those thousands of sensors, we're doing those 2 weeks exercise, and at the end of the day, people are getting 0 to 5 alerts covering their entire plant. Okay. Now, but on the other hand, to set the right expectations, because we are all analyzing data and we're all very proud of that. Remember that at the end of the day, it's not replacing the human thinking. It does not replace the professional people that are sitting there in the control room or the process engineer who eventually need to make a decision, what to do, how to act, choose from the alternatives. speak to me in 10 years from now, maybe, or 15 years from now, maybe it will all be automatic. And maybe it can be automatic for very specific cases. But the general rule is that we can take all these thousands of sensors, we can analyze them, we can show you the things are going to happen. You will need to make your decision what to do about it. And this is one of the major challenges that our customers are facing once you start using this predictive monitoring, once you start using the data, once you're doing this digital transformation. So if to go back to the benefits and now to how do we measure. So when you're applying this kind of solution, you actually want to be able to measure how well you've been doing. And there are actually three parameters that we'll look at. Two of them are really measurable. The third one is, it's again, we're back to gut feel. But if we manage to reduce the direct cost of failures, this is really money in the bank. I mean, this is more production that you can generate. If we reduce the number of emergency cases, of maintenance emergency cases, where you had to expedite parts or pay more for the vendor to get things, or pay people overtime in order to solve it immediately. If we reduce that, again, this is actual saving. And finally, the third parameter, which is hard to measure, but it's very, very important for the people who actually operate the plant, is that you'll get smoother operation. Because if you know about things in advance, you can get prepared. And when you can get prepared, it's a completely different way of operating the plant. So I will conclude by again emphasizing that darkest corners are always scary, are always danger. Okay, the danger for your plant may come from the compressor, but it can also come from all these hundreds and thousands of equipment parts which are out there. Now, you have the data. I'm sure that you have the knowledge about your plant. All you need to do is to make a decision to use the digital technology which exists today and to actually start monitoring this plant in a much, much better and predictive way. So I assume that we have questions now. So I'll be happy to answer any questions you may have.
So hi everyone, and thank you for joining us, and thank you for sending questions over. Chen, one of the questions here is asking, not every component is being monitored. For example, passive components are not connected to any backbone. How can you still get some predictive alerts on that?
Okay. So I would say that first of all, we are based on data. Okay, so if the more data, the better, and if there is data, then we're in a much better situation. But the other thing that we're looking at is what's the effect of that component. Okay, so you may not measure this specific pump, but the pressure that it's creating or the flow that it's creating is measured. Now, we will see some problem with the pressure. We'll see some problem between the pressure and some other things which are measured. We will not probably be able to tell you, listen, it's a pump, because you're not measuring anything about the pump, but we'll see that there is a problem in this area. So the more tags you have, the more data you have, the more measurements you have, the more pinpoint the analysis is. The less data you have, then you see more the effect downstream, and we're trying as much as possible to go upstream and find the root cause, but it will not be as pinpointed as things which are measured. So if, for example, we have the pressure and at the same time we have the current for this pump, then we may be able to say, okay, it's actually the pump. It's not just we see a problem here in the pressure, but we don't know exactly where it comes from.
Okay, thank you. Another question. How many types of data enter your system? And how do you handle the differences between the different types of data?
So from our perspective, we look at any type of data, time series data. Okay, so it may be flow pressure, temperature, vibration, current, as I mentioned, set points, position of the valves, and so on. So we take everything. Now, of course, the software has all kind of mechanisms in order to normalize the different parameters and actually come to a conclusion when something in the relationship between those tags, between this measured data, doesn't play right. Is not really according to the normal, because what we know, especially in the process plant, is that it's never one tag. It's never one thing that is actually that without any effect. So you would expect to see that if you're if you have the same set point, the position of the valve changing or not changing. Maybe if you add in the ambient temperature, you would see, yeah, I expect this position to change because it's colder or warmer outside, and so on and so forth. So what the software knows to do is to actually take all these conditions, normalize them to each other, because one is the temperature and the other is position, and understand that something in the relationship here is getting wrong. And now, based on the model of the plant, we are able to understand, okay, if this is going wrong, then it's probably this problem with the valve or this problem with the pump or some other thing, and try to point out where do you need to look.
Thank you. Now something a bit about a question about the employees. How do you find the reaction of the plant employees? Cooperative, reluctant to cooperate, afraid?
Well, it depends. Many of us are afraid of changes, so at the beginning you may find some reactions of, nah, we do it for 20 years, why should we change, and so on. But the overall is that people are looking to improve their work. Okay, and in this case, and this is again, when we talk about digital solutions, we usually characterize them by three categories. You have the black box, which basically tells the user, listen, I'm smarter than you. I'm a data scientist. I did so much analysis, and I know better than you. Here is the results. Take it or leave it. This is what I have. And this is a black box. Black box solutions are not well accepted. Then you have the white box, which actually tell the process engineer, listen, you need to become some kind of data scientist, and you need to write your own analysis. Okay, and this is, again, the process engineer has his day job, and he's probably not very happy to do that. What we're offering is something which is a gray box, because actually the quality of the solution will be determined by the way the operation people built their model, and they built it in their language, and they contributed to it, and they're part of the process. So eventually, when they see the results, they understand what's going on. It's their results. It's a combination between all the knowledge that they have and all the data science which was developed in the world over the last 50 years, and this is the best combination, and this is what making them more engaged and more accepting for the solution. So from my experience, I always hear some reactions here and there, but at the end of the day, if you manage to involve these the operation people during the building of the solution, then the acceptance is very good. And as I said, my belief is that these people are needed there for many years to come. I don't see any automatic solution that will completely take the human out of the loop in the operation of a chemical plant.
Another question here is asking us about our competitors. Who are our competitors?
Okay, that's a good question. So I would say like that. There are different approaches. Okay, so there are the approaches that, yeah, let's try to analyze things that already happened, and for that, you may have many vendors that can do it, and probably, you know, your own statistician in the plant who can take historical data, historical cases, run regression, try to predict the next time this thing would happen. And if this is your problem, then you're pretty much covered. There are other solutions who are trying to monitor the entire plant with less success, from the big companies. One of them is actually a partner of ours. We're partners with GE, but GE is also offering a solution called Smart Signal, which is also monitoring the entire plant. And there are solutions which are looking to provide a tool for the process engineer to actually write all kind of analysis on his own. And there I can mention Trend Miner, which is a very interesting tool. So there are tools out there. Okay, so if you're looking for statistical tool, for analysis tools, there are plenty of tools out there. If you're looking for predictive monitoring for your entire plant, with only few alerts a day, I don't think there is any adequate solution that will provide you that value.
So can you refer to some of your customers? Can you talk about them a little bit, maybe references?
Sure. So in terms of customers, I mean, we're working, as I said, we're focused on the process industry. We are our first customer who was actually, I would say, identify us was a BASF in Germany. We have other customers who appeared in conferences, and for those of you who attended the main days in Berlin last year, they may have seen a representative from Vaca presenting the solution. We have customers here from Israel. Bazan Group, who presented the solution in the ARC conference in Barcelona a few months ago. And there are many other customers who are not, which I cannot share their names, but if any of you would like to proceed and receive reference and meet customers and talk with them, this is of course possible, and we'll be happy to connect you to those customers in the relevant verticals that you're operating in.
Thank you. Another question here is about third-party small equipment like CNC machine, or you're only an operator and it's problematic to get the data out of the machine. So can we enter that into our analytics?
Yes. The one thing that we selected the process industry because it's very complicated, but the other nice thing about this industry is that the data is there, collected, you have history. I know it's not the situation for discrete manufacturing, or not for all discrete manufacturing, especially in the CNC machine and so on. I think your focus today need to be on how to collect the data from the machines, bring them to a center of storage, and start storing history. And for that, you can use either your own built-in solutions like were done in the process industry, or even jump one level further and go immediately to those platforms which are offered today, like MindSphere from Siemens, which is also a partner of ours, where you can actually take the data from the end machine, load it to the cloud, analyze it, and get immediate results. So from our perspective, we are not dealing with the actual collection of data from the machines. We're analyzing data which was already collected. But I think today, with all the partners and all the different platforms, you have pretty cost-effective alternatives that allow you to take this data and load it and start storing it. So in a few months afterwards, we can start analyzing the results.
So just saying to those of you who asked, so we are going to send the link afterwards, so don't worry. And one last question here. How many of the alerts generated are false alerts?
Okay, that's a very good question. And I think this is a question that need to be looked a little bit different. When you talk false alarms, this is where when you saying you're trying to predict a specific thing, and actually your prediction had nothing to do with the thing you tried to predict. And this is almost never happening in our solution, because we're not trying to predict a specific thing. We're seeing that the plan is starting to deviate from its normal operation. Now, these deviations may have different reasons. Okay, for example, if you're doing sudden maintenance on a part, probably during this maintenance it will behave a little bit different, and that will be something that we will may consider as abnormal event. We're trying to eliminate all these deviations which are really explainable, such as ambient conditions and all other things which are things that you don't want to see. But at the end of the day, and this is the important thing, you have 5 alerts, up to 5 alerts. And if you have up to 5 alerts and you spend few minutes on each of them, and one of them you say, oh yeah, it's a maintenance, we're doing maintenance there. And the other thing, you look and you say, oh, yeah, okay, this is I don't know. Today it's just hotter than anything that happened in the last year. The global warming, and the 3 of them are actually problems that you need to address. Then I think we're in pretty good shape. And this is about the what we're seeing from our customers.
So there's another one, and we still have a bit of time, so let's go for it. What is the customer satisfaction score of your company? Did you implement your tech in a steel company?
It's actually 2 questions. Yes, we implemented the solution in a steel company in continuous casting. So we have experience with that, and we have experience with the integration to EBA system, which is the historian widely used in the steel industry. And I think I can speak for our customers is that they're very happy with the solution. They're very happy with the number of alerts they're getting. If there is one challenge that they need to address, and which may influence their acceptance, is the ability to measure success. Because one of the things that we're telling our customers, it's listen, check how many failures they had last year, how many failures they have this year, and it will be very clear what's the value. Now, ask yourself whether you really measure what happened last year. Okay, and what we are seeing from many of our customers is that they are not really measuring exactly what was caused by unplanned shutdowns, what was caused by just no demand or things like that. So now you're in the situation where you're actually looking at the alerts and saying, okay, you told me that this pump is going to fail, and I actually changed it. And now you need to actually simulate how much money would you save. So this is, if I'm looking at the challenge for our customers now, the ones who are doing either pilot or production, and they're trying to see, okay, how much money did we save from all these alerts, from all these parts? And there are many of them which we told you, listen, there is a problem, and you went and fixed it and avoided whatever what. None of these customers, or almost none of these customers, is actually trying for each of these failures to simulate what would happen if, and what money would be saved then. So if I divide my answer to two, I think our customers are very happy. They're very happy from the reliability of the software, from the number of the alerts, from the accuracy of the alerts. I think the challenge for the entire industry, again, it doesn't matter if it's our solution or some other solution. The challenge for the entire industry is to actually reliably measure the success. Because if you prevent something and it never happened, it's very hard to know what would have happened if. And this is, regardless of the solution, this is the big challenge when we're implementing predictive solutions and predictive monitoring in specific.
So questions are keep coming in. How is your solution, the software, different from Predix?
Okay, excellent question. So I would divide the world into two things or two areas. One is platform. The second is applications. Platforms are those, platforms are provided usually by big companies. I wouldn't try to develop a platform myself. I think it's a huge challenge, and the rule of what the platforms are trying to do, are they try to provide the operating system for this entire thing. So they're the Apple and Android of your industrial plant. But this platform is actually useless unless you have applications running on it, and it's just like with your mobile phone. So if you're implementing Predix and now you have data, you gather data from all these different machines that you have in your plant, and you're gathering it into one place, and everything is great, but now you need applications. Now, some of these applications are provided by them by coincidence by the platform vendors themselves. So GE is providing APM based on Meridium, which they bought, and they provide other solutions which are using the same platform. But at the same time, what you need to evaluate is, okay, I got this platform, now I want the best predictive monitoring solution that is available out there. And then our rule, and what we're trying to do, is we're trying to make sure that we'll be integrated to all these platforms. So if tomorrow you selected Predix, I will be able to read from the time series service that Predix is providing, and it is providing, and it's something that we have done. And if you tomorrow selected MindSphere, I'm able to read from the time series service that MindSphere provide, and still provide you the value in a seamless way that you don't care. So it's a huge challenge for us as application vendors to support all these platforms. We sure hope that there will be some kind of convergence, and there will be some kind of standards which do not exist there today. But for you, in terms of customer, you're not evaluating an application versus a platform. If you think you need a platform, and you made your analysis, and a platform is what you need, select a platform, whether it will be Predix, MindSphere, or any other platform which is out there. If your problem is that now you have failures in your plant, and you want to prevent those failures, and you have the data, then I don't know if you need a platform, yes or no, but we can provide you an answer for this specific problem.
So what would the system do with multiple databases, not coupled, just multiple databases? Can you couple them to see general effects of the not coupled systems?
Yes, we're getting into technicals here. Basically, yes, we can gather data from different databases. We can merge them together. The only requirements that we have there is that it will have a timestamp. So if you have different databases that you're collecting data from, different EBA systems, different PI systems, different just database, we can merge them together, and it's just technicality. There is no real issue around it. You always have to remember that the garbage in, garbage out. So hopefully the data is there in each of these databases in the intervals which are reasonable. I mean, if you're measuring data once a day, it's of course not as powerful as data which is measured every minute, or every minute is about the interval that we're using. So technically speaking, these are not hard problem, as long as you're collecting this data. Okay, as long as the data is collected in a reasonable time interval, then merging it should not be your showstopper.
Challenging question. You made clear what's the main advantage over competitors, but what is the main drawback of your solution? What is the situation you're not able to tackle in comparison with the same competitors?
Okay. So the one thing I would say that the competitor that we really, that you can consider is when you're doing a specific analysis on a specific part. Okay, and because competing with companies that are only doing machine learning, I think it's there is no drawback. I mean, we're much better, we're much more focused, we have the context of the plan, so we can actually provide you the root cause and not just the anomalies in the data. So this is not where we have a drawbacks. The real drawback is when you're saying, listen, I'm going to analyze a specific compressor or a specific pump or a specific type of equipment, and I'm building the greatest analysis for that part. Okay, and actually what will happen if this analysis, regardless of the statistics, okay, if you'll have an alert about this triggered from this algorithm, you can also develop a clear path of what should you do then. Okay, so the one advantages of doing a very specific monitoring is that it's a very specific solution. You can decide in advance and plan for a very specific solution, and this makes lives much easier. Now we are monitoring the entire plant. Okay, everything can fail. We cannot, and I don't think any operation people in the plant can plan all the scenarios that we can trigger an alert. So the drawback of our solution is that it requires people to look at the alerts and make decisions. If you're doing a specific analysis, you may make the decision in advance. If this algorithm is triggering an alert, immediately turn off this pump. No questions. For us, when there are so many options in the plant, we actually need the person to look at the alert and decide what to do. Now, the good thing is that this person is there. Okay, you have people in the control room. They're trained. They know their plant. You have a process engineer there. Yeah, he has less available time, but he's trained. He knows how to look at the alert. And all in all, you have up to 5 alerts a day. So from my perspective, when you're balancing whether I want to do a specific analysis or whether I want to monitor everything, of course, the best answer will be let's do both. Okay, because why not do a specific analysis for this and also monitor everything? But if you have a choice, then I think most customers and most plants will decide to let's cover any danger in the darkest corners and not just look under the spotlight where I'm really looking at that.
Well, thank you for sending so many questions. I'm not sure we're going to be able to answer during the webinar everything, but afterwards we're going to answer your questions in emails, etc. So your questions are recorded. Is this new technology? How long has this type of technology been available?
Okay, so basically the technology that we're using is merging two approaches, and that's, I think, what makes it interesting. The one approach is machine learning, which is there for many years. Okay, of course, we developed and we have the best algorithm in the world for machine learning, but machine learning is there for years, and statistics haven't changed much in the, I would say, last probably 30 years. The second discipline that we're using is system engineering. And what we came to conclusion is if you merge the ability to build a model of your plant together with the machine learning, then you're getting a much better result, because you're actually merging between two things. One thing which is analyzing the data, and another thing which is analyzing the knowledge that people have about their plant. And the combination is that by using their knowledge, you're actually can look and screen all these anomalies, all these results of the machine learning. So the technology, the base technology on both disciplines goes years and years back. When we started to connect them around 2012, something like that, we saw that this is something that was not in the market. I mean, people were either data scientists and they were deep in their data science, or system engineers and they were deep into designing plants. And the combination was not available, and we don't see it available also today. But this is what makes our technology so special, unique, and powerful.
This will probably be our last question about our price range.
Okay, of course, I will not refer to actual prices here in the in this forum. It depends on geography. What we're trying to do is we're trying to link our pricing to the value. Not directly, of course, because we don't want to go into your books and into how much profit you're making, but in a general in the general term, we know that a plant is producing, so we tie our pricing to the plant, so it's a price per plant. We don't want to hold you. I mean, we don't want to catch you and say, listen, you're ours now for good, and this is why we select annual subscription. So you want to go, you can go. You don't have to. You're not taking commitment for 5-10 years. I don't know if tomorrow there will be a better technology in the market. You're more than free to stop and change to another technology. So these are the two criteria which are very relevant for us. One is the pricing is per plant, because this is the value. This is where you see the value. The second is that we're not holding anyone from leaving us, and it's reasonable. Okay. The one thing that I think it's true about the software is that it just costs a fraction of what other things would cost. It's not the cost of people. It's not the cost of hardware that you need to ship from place to place. Installing a software is very simple. So the overall cost of ownership is fraction of what you're used to, and within the budget that the plant manager can certainly approve without any problem. Okay, I would like to thank you all for joining and for all the questions, and we will be happy to answer. I mean, I think you will get all this this presentation and material by email, but we'll also be happy to answer any questions you have. Please feel free to approach us. You have our emails here on the presented in the slide, so. We'll be more than happy to get a call or email and provide you more details, whether it's about the strategy of predictive monitoring, or whether it's about our solution and where it's applicable and what can be the ROI for your plant. So thank you very much.
Thank you, guys.